Okay, hello and welcome to my channel. This video is the first of the series called Engineering Dynamics, which you guys will be learning how the dynamics of the rigid bodies works in the real world and also in the textbook problem that I will be guiding you step by step on how to solve it. We first start with a very fundamental concept problem and then advance into more interesting and advanced problem. Okay, so this is the first problem for the projectile motion. It will be very straightforward. I want you guys to follow along as what I explaining and describing the step. Okay, so without further ado, let's start problem statement. How to let's interpret it, what we know and what they ask us to solve for. Okay, so first, a pilot delivering mails to some location. So say that location is point A, for example, and they said that he maintains altitude of 150 meter and a constant speed around 250 kilometer per hour, as shown in the slide here. Okay, so they ask us about the angle data, that what should pilot be dropping this passage so that it will fall as exactly at point A, like shown in this motion here. Okay, so first, what do we know? We know first the altitude of the plane. Second, we know the speed of the plane. Okay, and we are given by the gravitational acceleration. So that's all we know. Okay, so first thing first, you may have already noticed that the unit here is not consistent, meaning that they use meter in height, they use meter per second square in acceleration, but the speed they're giving us, for example, the speed of the plane is 250 kilometer per hour. So to reduce the inconsistency in the term of units is very important when you're dealing with the problem that has multiple units. So I would like to introduce the unit conversion method I have been using. So firstly, we have 250 kilometer per hour, and then we would like to change the kilometer per hour into, let's say, meter per second. That will be more convenient. Then we track back of how 1 kilometer would be equal to 1000 meter. So by that equivalent, we cancel out kilometer away and will leave us with meter per hours. So we change meter, we change hours into minute. Okay, 1 hour is 60 minutes, so we cancel out the hour. Now we want second, right? So in 1 minute it contains 60 seconds, so that the minute cancel away, and then we get meter and second. So do the multiplication, we got around 69.4 meter per second as equivalent to 250 kilometer per hour. Then for a short or more like to memorize this formula, you can easily say that 1 kilometer per hour is equal to 5 per 18 meter per second. But I would like you to be more focused on the way I cancel out the unit so that it would work in any unit in the world. But if you have like a strong memory, you can also memorize this term. But don't forget to understand how it comes from. Okay, so let's talk physics. Okay, first, we know in projectile motion we have not so much equation involved. We're using more or less repeated equation to solve. So in this case, I focus on the sy, meaning the distance in y direction. Okay, so first, okay, sy or s equal to u times t plus 1 over 2 acceleration time square. Then, okay, so sy here, distance in y direction, equal to the initial velocity time again plus 1 over 2 t square. We notice that the velocity in y direction there has no information about that. The plane fly horizontally, so there will be no velocity in that term, so we cancel out and give it 0. Okay, so you notice that the sy I put is in minus sign, despite the fact that we know this 150 is at a minus sign here. Reason being is that you can see on your bottom left corner, I wrote the y and x axis positive sign, so meaning that the y point, the positive y point upward, positive x point toward the left, meaning that everything that go against this direction should be minus sign. So that's what I put in every problems. But from now on, I want to introduce you to this kind of reference frame so that you guys will have a common understanding. Okay, so of course you can set x into the opposite direction as I did, but make sure that it's consistent along of all across the solution you have making. Okay, so sy here has minus sign because go against positive y again, and the g side, the acceleration here minus because it again is go against y direction. Then after we compute it, we will left us with the time that would need it from the start of the dropping point until it reached the ground, around 5.53 seconds from the calculation we did. Okay, so now that we know the time needed from the package to fall to the ground, we would know the amount of distance this plane travel in horizontally. Okay, so the velocity here is 250 kilometer per hour or 69.4 meter per second. We can easily determine the horizontal displacement by s equal to ut. Okay, now s equal to the velocity here, the time needed for the parcel to be placed on the location. That means the distance in horizontally will be 283 meter. Now we know this distance, and we know this vertical distance. You can easily determine the data. The data will be this side 150 divided by the distance in horizontal axis, which is 283, and if we do the math, we've got data equal to arc10 0.391. Put on the calculator, it will return into around 21.34 degrees. Okay, so that's it. That is the end of this problem. We already know the time needed for parcel to travel. We know the data that is acted between the horizontal line and the pilot line of sight, which is 21. Okay, thank you for watching. This will be the end of the video. Please be sure to check out another videos regarding another projectile motion in the channel. So thank you so much for watching. I hope you guys can learn a thing or two from this video, and I'll see you guys on the next one.